Hello, advanced quantitative reasoning students. I hope you are all doing well. We're going to start student activity sheet 3 today, time value of money. We'll be looking at time value of money quite a bit from here on for maybe most of the rest of the year here. All right, so what they're giving us is a table that says the future value of an investment is the amount it will be worth after so many months or years of earning interest. Following table lists the savings account future value in selected years. So we've got a table from 0 to 30 here with all these different balances. And on number 1 and number 2, what they're asking us to do is first make a scatter plot and then calculate the regression equation. Okay? So I'm going to show you how to do this in Desmos. I showed you on the last video how to do the scatter plot. We're going to add on the regression equation this time. We're using Desmos.com. So let me get this out of the way. And let me just show you. Sorry about that glare. Let me see if I can fix. No, that didn't help. All right. Can't really do anything about the glare. Sorry about that. Anyway, you're going to press Start Graphing, just like yesterday. We're going to go up here. Maybe if I do this, that'll help a little bit. We're going to go up here to the plus sign and we're going to put in a table and you're going to type your numbers in. Now I made a table with different numbers just to kind of go through it. So I'm going to use this different numbers and you can just watch for right now my process at any time. I'm going to leave that. At any time you can go back and pause it and rewatch it or whatever. So you can see I have 0 through 30 just like y'all have in your table, but I have different Y values here. Okay, so that's my balance. I started at 4,000. The one on your paper starts at 2,600, and it goes up by some amount every year. Okay, so once you have that, you're going to come over here. You're going to hit the little wrench to set your window. So -2 to 35 is going to work fine for your x-axis. That's going to be able, so you'll be able to see the y-axis very well. You can see down here at 4,000, I've got a dot. Well, I guess you can't see that. At 4,000 down here, you can see a dot here, and then up to 35. That's past 30. Our last value is for 30 years, and so we want to be something greater than 30. I put 35. For the y-axis, for mine, my values. Let me skip back over here for just a second. My values go up to about 12,000. Okay, on yours it only goes up to about 9,000, but you want something bigger than that biggest y value. So I went up to 15,000 here. And that's going to be in dollars. So from $0 to $15,000. And so once you have your windows set, you can look, and I have a nice little pretty, there's my scatter plot. You know, there's not a lot of curve to it. And so we've done the scatter plot. And you can kind of draw a sketch on that, maybe out next to your table or something. Okay? All right, so now we want to find the regression equation. So this is just slightly different. And at any time, if you don't understand my instructions, you can Google Desmos space regression, and that's how I did this. That's how I figured out what everything was. Okay, so I want to come up with a regression equation. I'm going to hit the plus sign again, and this time I'm going to hit that very first line that says expression. And so I'm going to try again. You know, I've been telling you that it's always going to be either linear or it's going to be exponential. So let's look at both of those real quick. So I'm going to do linear first, and I'm going to type in y, not a capital Y. I'm going to put y, and I'm going to hit the underscore, and that'll make it y sub 1, and that fits my table. My table has y sub 1, so I want a y sub 1 there, and the underscore will make that a underscore sub 1 there, y sub 1. So I don't want to put an equal sign. Normally I put an equal sign here, but I want a tilde, and the tilde button on your computer is right up here above the tab. Okay, so shift, oops, I hit a 0 instead of the shift. All right, so shift tilde. Okay, so I did shift tilde there. Now I'm going to put mx sub 1. So again, I'm using the underscore there to get the sub 1 plus b. All right, so here's my line that makes. Okay, this is a regression line that goes pretty close to all these points. It's not perfect, but it's pretty close. the equation of that line would be approximately y equals m is 266.047, x plus b is 3,437.87. And you can see the r value. The r value tells you how good of a fit it is. The closer that gets to 1 or -1, the better it is. And this is really close to 1. It's 0.9877, almost 0.99. So that's really close to 1. That's a really good regression equation. Okay, but let's see how it does with exponential. All right, so I'm going to come back up here. I'm going to backspace to get rid of that stuff, and I'm going to say, remember, it's y is equal to a times b, and now I want an exponent, so I'm going to use shift caret here. Above the 6 is my little caret button right there. So shift, and that makes, you can see that changed it to a power here, and I want x underscore 1. All right, and so now look at that, r squared value is 1, which means r is equal to 1, and it hits every single point exactly. It's every single point exactly, so this is a perfect equation. And this equation is going to be, my a value is 4,000, my b value is 1.0375. All right, so if you need to replay that, do that, take some time, do this, and then come back and we'll go through the answers for 3, 4, and 5. So I'll give you, just pause your video and come back in a minute. So we had an equation. I'm going to put my equation here. I got the equation y equals, for mine anyway, 4,000 times 1.0375 to the x power. That was my equations. It says, according to the model, what is the interest rate of the savings account? Well, your interest rate's related to this number right here. Okay? Remember that number, this is called our growth rate, and it's equal to 1 plus r, where r is our interest rate. So if I took that 1.0375 and say that's equal to 1 plus r, if I subtract 1 from both sides here, that's going to become 0.0375 equals r, my interest rate. So to change that to a percent, that would be 3.75%. So that is my interest rate on this savings account. And it's compound interest. Anytime we have exponential growth on these things, it's going to be compound interest. If it's simple interest, we're going to use that linear. The linear is simple. This is simple, linear. Compound is going to be exponential. And that's how we know. Okay? So once you have your equation from up here, it says how much will be in the account in 50 years. We'll just put in 50 for x and figure that out. So on mine here, it'd been 4,000, and obviously I'm going to get a different answer from y'all. If I do that to the 50th power, I'm going to use my calculator real quick here. 4,000 times 1.0375 to the 50th power, and I get a pretty big number. It's $25,203.76, and we're going to round it to decimals because that's our nearest penny. Okay? So, looking at this regression equation here, we want to write a general formula for future value of investment compounded annually. All right? So, y is my future value. 4,000 is my present value. What is it worth right now? This part in here, remember, is 1 plus r. In this particular case, they use I. I don't care if you use I or r, whichever one. In fact, I'm going to use r here. 1 plus r. And then my x value is going to be my time. How many years? So that is our equation to find the future value if I know the present value right now. Okay? Last question is number 6. Number 6 is going to ask you, well, what if it's not just compounded annually? What if it's compounded 4 times a year? Or what if it's monthly, 12 times a year? How's that going to change your equation? So I want you to think about that one, and we'll start tomorrow's video with that. Okay? I will talk to you later. Bye-bye.